So we're into the home straight and the final video of the trigonometry and Pythagoras section of the course, and certainly for now. And example 21 now takes us with, as you may remember, with Pythagoras' theorem, we started off with just right angled triangles, and then right towards the end, or when we started solving some problems, we then introduced the idea of an isosceles triangle and how we could split an isosceles triangle in half, and then we ended up with two right angled triangles. Well, the same thing obviously applies with trigonometry, and to start with in this question we're given the two similar sides, but we're not given the third side of the isosceles triangle. And we're asked to find the length x, which is the length on the bottom there. Okay, so what we're going to do is we're going to imagine that this triangle is split. We don't have to imagine it, it is split down the middle there, like so. And then what we can do is draw that triangle over here and put on the right values. That's not a very good line. Let's make that a bit better. Put on the values. We've got a right angle. We know that this is 53 degrees. We don't know the height. We do know that this is 7 centimetres. And this now, well, we've got different options here. I'm going to call it y. Okay, we'll call that length there at the bottom y. But I am going to just scroll down a bit and make it a bit bigger so that you can see it a bit easier. So this is our problem. We've got one angle and two sides. We've got an angle and two sides. So adjacent and hypotenuse means it's cosine. So it's cos theta equals a over h. Fill in the right information. So cos 53 equals y over 7. So y is 7 cos 53, which we can calculate to being 7 cos 53, 4.212 or 213. Now, that isn't the solution, obviously. The question wants us to work out the value of x. So we need to then say x, let's try that again, x equals 2y. Because obviously y is half the length of x, so 2 lots of y will give us what we need for x. So x equals 2 times that value we just found, which I've left on my calculator, and that is 8.42541 ... which is 8.43. So 3 significant figures. Okay, so there's part A. We have worked out x. Then it says work out the area of the triangle. Okay, now the area of the triangle, that means I'm going to need the perpendicular height, that distance from the base up to the top. So really I'm sort of talking about this bit here. Okay, well we've got different options, haven't we? Bearing in mind we've now calculated y, we can say that that is 8.4, that's a lie, that's not 8.43, is it? That would be longer than the hypotenuse. That's the first answer of 4.212 and so forth. So I've got two options. One is I could use Pythagoras because we've got the hypotenuse, we've got one of the shorter lengths, and we're trying to find that height initially to be able to work out the area. So I could use Pythagoras, which would be fine, but actually I'm going to use the angle and the hypotenuse, and the fact that I'm trying to find the third side means I can use trigonometry. So I'm going to do that. I'm going to scroll down just for a second and go to my triangle there, and we'll just use some quick trigonometry to solve. So what have we got? We've got, if this is the angle, 53 degrees, opposite in the hypotenuse, so that's sine. That seems a bit thick, that. So let's make that a bit thinner. So we've got sine 53 equals h over 7. So h is 7 sine 53. And 7 sine 53 is 5.59. Okay, so that's the height. Now, area of the triangle then is a half times the base, but the whole base is that value x that we found, which is over here, 8.43 ... times the height, which is this 5.59 ... So I've got quite a lot going on there. So what I'm going to do, just to make sure I'm really accurate, is I'm going to be a bit smart. I'm going to start by saying that that is still a half times. Now this 8.43 is the answer we got over here. Okay, now that is actually 2 lots of this answer, and this answer is 7 cos 53. So 2 lots of 7 cos 53 must be 14 cos 53. Okay, now the reason I'm doing that is because this 8.43, I didn't write enough down. I only wrote down 4 or 5 decimal places. Obviously that probably is enough, but to be really smart, I'm going to use the exact value, that 14 cos 53, and then I'm going to multiply it by the value we found for h, which again I'm going to actually write as 7 sin 53. Now this one's not such a problem because I've still got that on my calculator display. That's 5.590444857. So that one's not such a problem, but I'm going to take this answer, I'm going to multiply by 14 cos 53, and then I'm going to divide that answer by 2. And I get an answer of 23.550911155, which is actually 23.6 if we round to 3 significant figures. It's probably worth, in fact I'm certain it's worth, putting in our units. Looking at the original question, it was centimetres. So this is centimetres squared, and there we have it. We first off found the base of the isosceles triangle, and then from that we can calculate the area. But we're in the same zone as when we were doing Pythagoras' theorem. If you're given an isosceles triangle, splitting it into 2 right-angled triangles means you can then use the trigonometry that you've been learning. And that about wraps it up. Of course, there may be other videos going through questions that you've been struggling with. I may do some videos or just written solutions. As you get this is a real mammoth amount of work here that you've got to complete. So as you're going through step by step, bit by bit, I hope it's made sense. I hope you've utilised the resources you have available to get through and be able to understand all the trigonometry that we've been working on. As always, any problems, questions, anything you're not sure about, you can come and find me, and I'm happy to go through it with you. Anyway, thanks very much, and all the best.